Hey, Nathan here from PH Studios, and welcome back to another tower defense video covering the game engine. Last tutorial we discussed some user interface sections and classes for like the button and image, and we're going to continue on that path, and we're going to talk about the text class today. So just like always for the user interface ones we've added in the past, let's add two using statements. Using Microsoft.xna.framework.graphics, and then using Microsoft.xnative.framework. Alright, so the text class is going to be similar to the image class, where we have a text value that we want to display, which is just a string. Just like the image, we already have a way to display an image by using the texture 2D. For this case, we already have a way to display text using just a string value and the SpriteFont. Now we want to add a way to extend the capability to one class and have like its position, its dimensions, its rectangular bounds, and all that stuff. Similar to the image class that we created, we had our position and our rectangular bounds. And it gives us more properties, and we can say we can have a text object instead of relying on multiple objects everywhere in our game engine. So that's what we'll do for the text class, is use the string as a text value, and then a SpriteFont and all the other information that goes along with text, like dimensions, position, and all that stuff. Alright, so when we have a text, of course, what we'll have is a value for that text, and that will be a string value. So let's go ahead and make the private field as string text value, or whatever you want to call it. And then we want a public property that is a string, and let's just call it value. Now we have a get, and we return text value, set text value is equal to value. This is why I did not use just value as the lowercase value as the field name. It would just make it more confusing. So I just did a text value. Alright, so that's it for now. For the value, we will add some more logic into the set block. This is why I created a separate field to go along with it. Alright, let's do the same thing with the SpriteFont. And again, we're going to create a field to go along with the property, because we will perform more logic. And let's create a public property to go along with that. SpriteFont, and let's just call it font. Get return font, set font is equal to value. Alright. Now we need a way to calculate our dimensions of our string by using the SpriteFont. We want to store that in the class, because we do not want to recalculate it every time we want to figure it out. It'll just save us some performance. So we have a public vector 2 for dimensions, and we have a get and private set. Now we do not have fields to go along with this property, because we don't have to do any more logic than what you see here. Alright, for position, we have a vector 2 position, and we create a field first and then the property, because we want to perform more logic in the property. And then we have a get as return position, set position is equal to value. Alright, so some more physics data like velocity, we'll need to add that as well. And we do not need to perform more logic, so let's just go ahead and create the property. So we have velocity, get, and set. We set this up as public set. Alright, so let's finish up the properties here. We will need a rectangle object so we can store our rectangular bounds. So it's going to be a public property, rectangle, object. Let's just call it rectangle. And get and private set. Alright, so we have a few properties we still need to finish. Remember at the very top, we have a string value property, and we actually had to write get and set because we will perform more logic here. So go ahead and modify the set block to be in a new line like it appears here. And let's just do an if condition to check to see if the SpriteFont, which we just called font, is not equal to null, which means we already have a SpriteFont set up in our text object. Then we need to set dimensions is equal to font.measure string, and then we measure based on the value. And that will give us the dimensions in a vector 2, so it'll give us the width and height of the SpriteFont. Actually, the string value that the SpriteFont uses. And now we need to set the rectangular bounds that we just created down there at the bottom is equal to new rectangle. And then we use position as the first two, and then the dimensions as the width and then the height. So we need to cast all of those since the dimension is a vector 2 and position is a vector 2. So we need to cast those as integers. So it's cast it as an int position.x, cast it as an int position.y, cast as an int dimensions.x, cast as an int dimensions.y, closing parentheses and semicolon. So whenever we set the string value, if we already have a SpriteFont set up, it will calculate the new dimensions because we changed the value. Then it will set the rectangle to the new rectangular bounds. Now we need to do the same thing for the SpriteFont. So if we change the SpriteFont, we need to change the way that our dimensions and rectangular bounds are set up. So dimensions is equal to font dot measure string and then text value. So we set that up as dimensions. We get a new SpriteFont, and then we create a new dimensions vector 2 because we just changed the SpriteFont. So now we need to do the same thing we did above. We can actually copy this line of code here and then paste it. Now, when we change the position, the only thing that will change are the rectangular bounds. Changing position does not modify the string that we have in the text, and it does not modify the SpriteFont. So we're fine on those two accounts. We just need to reset the rectangle because we changed the position. And you can actually copy that same rectangle line and paste it in the vector 2 position property. Alright, so now onto the methods. We have a few constructors and an update and a couple draw methods. Because we have a SpriteFont, so we want a way to draw that. Alright, so first thing up is the first constructor, so public text, opening parentheses, of course we have string value, SpriteFont font, vector 2 position. So this will be the very basic way to get the text set up. We give it a sprite font, and we give it a vector2 position, and of course the value. And then we just need to set those up. So value, capital V, is equal to lowercase value. Font, capital F, is equal to lowercase font. Position is equal to this position here. Alright, so now we even have a more basic way to set up a text object. And that is just with the string value and vector2 position. So this does not contain a sprite font. In this case, we will depend on another section of the code to provide the sprite font and actually draw it. So we set value, capital V, is equal to the value that we passed up here. And then position is equal to the position we passed up here. And that's all we need to do for that constructor. Another basic one, we have public text string value SpriteFont font. So instead of the vector 2, we get the font, the SpriteFont we use. So value is equal to the value we passed here. Font is equal to the font we passed here. Alright, on the last constructor, public text string value, vector2 position, and vector2 velocity. So just pass it the position and the velocity. So value is equal to value, the value we passed up top, up here. Position is equal to the position we passed, and velocity is equal to the velocity we passed. Okay, so anytime we have any sort of position or velocity, we might want to update that. So let's create an update method, and it'll accept game time, and it will just say, let's calculate the delta seconds between the last updates. So in order to do that, we have a float delta seconds is equal to float, cast it as a float, game time dot elapsed, game time dot total seconds. This comes as a double, so we cast it as a float. Now we just have position plus equals vector2 dot multiply velocity, comma, delta seconds. So we're using seconds to manipulate our velocity and add it to position instead of depending on the game loop. Alright, and of course whenever we have a sprite font or any user interface elements, we obviously want to end up drawing them at some point. So we need to create a draw method, and that needs a sprite batch, and then the color we want to use. Now, there are a few constructors here that don't accept sprite fonts, and you are in no way required to enter a sprite font. However, this is going to assume that the sprite font is already existing. So let's just do a quick check. If font does not equal to null, then we want to draw. If it is null, we will just ignore this method and we won't do anything. So we call SpriteBatch.drawString and we pass it the font, value, position, and then color. Font is the field, value is a property, position is a field, and C is the parameter here. Now we have another draw method that does not expect to have the SpriteFont already created and already stored by us. So we have a SpriteBatch, SpriteFont, font, and then color C, the color we want to draw. Now this will assume that we do not have a SpriteFont in this object. Or if we do have a SpriteFont in this object, we might want to use a different one. So let's just call SpriteBatch.drawString the font, the text value, the position, and then the color. Alright, so that's pretty much it for the text class. Now there's one thing we still needed to do in the button, and when we draw it, we need to draw the text. So let's go to the button class, and on the comment, or delete the comment line we have in the draw method, and then check to see if button text is not null. We will draw it. Button text dot draw. Pass it the sprite batch, and then we pass it the forecolor of our button. Alright, so we're getting pretty close to finishing up the user interface sections. So next up we will discuss, I think we're onto the UI blocks now, aren't we? Wave information, user information, map region, command info bar, and UI block. So let's go ahead and start the UI block for the next tutorial. I hope to see you next time. Thanks.